This is the third of 5 lectures on weight control and obesity. I am Gary Horndeski, MD, board certified plastic and reconstructive surgeon, and author of Weight Regulation and Curing Acquired Obesity. Physics is a scientific study of nature. Mathematics is the language of physics. To solve the complex problems of weight control and obesity, it is necessary to use applied mathematics. When I was in undergraduate school, control system theory was required for an electrical engineering degree. In medical school, physicians learn about control systems, but not the mathematical details required for a complete understanding. There are several models of control system, but the most precise system utilizes negative feedback. It is required that whatever is being regulated must be sensed. Then the sensed signal is used to oppose change. The 3 components of a regulated negative feedback control system are the reference R, a constant value, amplification A large number, which usually varies, and feedback F, a constant number less than 1. From this model, output O is equal to R times the quantity A divided by 1 plus AF. The mathematical product of A times F is the critical factor to determine 3 possible dominances of the control system. If AF is much greater than 1, then A divided by the quantity 1 plus AF is equal to 1 over F, and the system is feedback dominant. If AF is much less than 1, then A divided by the quantity 1 plus AF is equal to A, and the system is A dominant. If neither of these 2 conditions exist, then the system is non-dominant, and A divided by 1 plus AF is the determined value. Regulated systems with feedback dominance are the most precise. The result is the output O equals R divided by F is a constant value since both R and F are constants. The output is independent of amplification variations as long as the critical product, A times F, is much greater than 1. This is a difficult concept to understand, but essential for understanding weight regulation. Before leaving control system theory, there's one additional concept to discuss. The reference R may be composed of multiple references, not just one. Also, a reference may be located within the negative feedback. It is important to understand that a negative valued reference in the negative feedback loop is mathematically the same as a positive reference. Weight is the sum of lean weight and fat weight. We have seen that in stage 3 of the length and weight for age graphs that growth terminates and lean weight stabilizes. Obesity is the result of excessive fat. It is important to understand how fat is controlled to determine weight regulation and obesity. A meal is terminated when satiety is achieved. Satiety can be achieved in minutes, but meal absorption requires hours. What property does a meal have prior to absorption that the body can sense to produce satiety? Food has multiple properties, including smell, taste, appearance, temperature, weight, and volume. Multiple studies have shown that satiety is achieved by volume. How is meal volume sensed? Within the muscular layers of the stomach wall are intraganglionic laminar endings, which are tension receptors. Wall tension originates from pressure inside the stomach expanding the stomach wall outward and pressure within the abdominal cavity compressing the stomach wall inward. The stomach is capable of holding a volume of 1 to 4 liters, and the walls are weak. When the stomach is not contracting, food within the stomach generates little pressure. However, the stomach is within the abdominal cavity, and the abdominal wall is much stronger than the stomach wall. Meal volume within the abdominal cavity increases intra-abdominal pressure, which increases stomach wall tension. Wall tension T equals stomach radius R times intra-abdominal volume P by Laplace's equation, T equals R times P. The abdominal cavity is a closed container. Once volume reaches capacity, V sub C, the pressure rises rapidly, depending on the stiffness S of the abdominal wall, where pressure equals stiffness times V minus Vc. All the contents of the abdominal cavity can be classified as meal volume, fat volume, or non-fat volume. Meal volume within the abdominal cavity varies with ingestion, absorption, and unabsorbed residual. Intra-abdominal fat volume is a fixed number D, less than 1, times total fat volume. Non-fat volume is determined by all the internal organs in the abdominal cavity, including liver, spleen, kidneys, pancreas, uterus, ovaries, etc., which have fixed volumes. The capacity of the abdominal cavity minus the non-fat volume is a fixed volume, and the volume available for intra-abdominal fat and meals. This creates an inverse relationship between intra-abdominal fat volume and meal volume. If a person does not eat for a long period of time, intra-abdominal fat is consumed to supply energy needs. When food becomes available, there is more volume available for ingestion prior to achieving satiety. Tension on the IGLs depend upon the stiffness of the abdominal wall, the volume capacity of the abdominal cavity, intra-abdominal non-fat volume, intra-abdominal fat volume, and meal volume. Since intra-abdominal fat volume is a fixed number D of total fat volume, IGLEs indirectly sense total fat volume, which is required for total fat volume regulation. The IGLEs function as transducers that convert tension to volume by the equation volume equals K times tension T. The volume signal is transmitted using pulse frequency modulation through the vagus nerve to the nucleus tractus solitarius, then to the hypothalamus. Within the hypothalamus, the feedback volume signal is compared to the internal reference R. When satiety is achieved, the brain terminates meal consumption. Meal volume has several components: fat, protein, carbohydrates, and fiber. Fat volume amplification A has 3 components. The brain's amplification of the volume signal is the meal volume A sub B. Fat volume concentration of the meal is A sub C. Fat volume absorption of the meal by the intestines is A sub A. Fat volume concentration varies exponentially. Low fat concentration 0.5% corresponds to fruit and vegetables. Medium fat concentration 5% corresponds to chicken, bread, corn. And high fat concentration 50% corresponds to bacon, chocolate, nuts, and butter. Fat volume absorption is normally 97%, but can be reduced by drugs or bariatric surgery. Fat volume amplification A and fat volume feedback F have been physiologically elucidated. Mathematically, A is equal to meal volume times fat volume concentration times fat volume absorption. Feedback volume signal is K times the radius of the stomach times the stiffness of the abdominal wall times the quantity, meal volume, plus fat volume, plus non-fat volume, minus capacity volume. Note that non-fat volume minus capacity volume is a fixed negative number within a negative feedback signal. This mathematically generates a positive volume reference, which was previously determined by the pediatric length and weight for age graph equations. In summary, IGLE tension receptors in the abdomen indirectly sense total fat volume. It is well known that the neuromechanical baroreceptors in the aortic arch and carotid body sense arterial blood pressure. Weight and blood pressure are sensed and regulated by similar neuromechanical control systems. Thank you.